3 dimensions. So we've got our point P. Here's our point P. Here's our point Q. We need to find a line going through them. Somewhere you would have an origin. So you know this position vector is 1, 5, 3. You know that this position vector is 2, 0, minus 4. Obviously, this is not drawn to scale, because now we're dealing with something in 3 dimensions. If I want to find this line, I need a point to start with. Well, obviously, we have a point, but I also need the direction. The direction it's going is from P to Q. Or you could do Q to P. It really doesn't matter. How do I find P to Q? Well, I would take 1, 5, and 3. Negative, because I would need to go starting at P back to O, then add 2, 0, negative 4, because once I get to O, I need to go to Q, and that would be the resultant red vector. So PQ is 1, negative 5, negative 7. And so our vector equation of the line will be 1, 5, 3. You can choose either of the points, plus T, 1, negative 5, negative 7. Yes. The R is like any point. So it'll be any 3-dimensional point on the graph. And T can be any number. So if T is 2, then I'd have 1 plus 2, 5 plus negative 10, 3 plus negative 14, and whatever point that would be on the line. Yeah. So like what it's saying here, like you see that our direction vector right now is this one, right? If I wanted to find this point here, then my T, I'm going to start here at P. My T would probably be negative 1, because I would need to go in the opposite direction the same length. And I find that point. If I wanted to find this point, then T would be negative 1/2, because I'm going opposite direction halfway. And I can find any point on the line by just changing T. You could do Q here instead of that, yes. And you could have chosen this direction as well, would be right as well. Okay, part B. Part B says, does the point negative 1, 3, 5 lie on the line? Well, if it lies on the line, okay, if it lies on the line, and this is where our parametric equation, so we've written out our equation right here, R equals 1, 5, 3. I'm going to just take that picture of that for our next screen. Here we go, paste it here. So here's our equation. According to this, we have this as a parametric equation, this as a parametric equation, and this as one of our parametric equations. So if the x-coordinate is negative 1, can you see that you can figure out what t is? If x is negative 1, then I would have negative 1 equals 1 plus t, which implies that t is equal to minus 2. If y is equal to 3, you would do the same thing, plug in 3 for y, and what happens? 3 equals 5 minus 5t, and if that point is on the line, we need to get t to equal minus 2 again. But this time, when I move the 5 over and divide, I'm going to get t equals 2/5. At this point, we know it's not on the line. But even if we had gotten t to be equal to -2 at this time, we would still need to check the final point for z, and this is when z is equal to 5. Well, that would mean you'd have 5 equal to 3 minus 7t, which implies move the 3 over to t is equal to 2 over -7. All three of those would have to be the same in order for the point to lie on the line, because any point can be found by plugging in any value of t and then figuring out what the corresponding values would be. So that point is not on the line. How about this point? You try it on your own. So again, I'm going to steal the parametric equations from the last one. So if x equals 3, y equals -5, and z equals 5, plugging them in, you'll get 3 equals 1 plus t. This would imply that t is equal to 2. -5 equals 5 minus 5t gives you that t is equal to 2. So exciting. And then, oh no. T is equal to -2/7. So this one is not on the line. Not online. Not online.